Um, so station one, what type of mixing is happening? It's additive mixing because all three colors, when you add red, blue, and green, red, blue, and green, you get a white light. That's because that's how additive works. And then station two was the opposite. It was subtractive mixing. So you had cyan, magenta, and yellow, and those three colors made they didn't make any light. They canceled each other out. Station three, explain why a rainbow emerges from the prisms. Um, this is because the different wavelengths of light are refracted differently. This causes them to disperse into a rainbow, with violet being reflected the most and the red being the least. Um, explain why you see an American flag with the correct colors. You see the correct colors of the American flag when you look at a white surface, because staring at a negative flag causes your photoreceptors to tire out. So when you look back at a plain white surface, you see the opposite colors that are not tired out. Station 5, give one reason you think the optical illusions are possible. Um, Optical illusions are possible because our brain perceives light, or our brain perceives objects relative to each other and not in absolute terms. So things can look bent or different size depending on what is around them when they're actually not bent or different in size. Um, Station 6, why does the amount of light passing through two filters change as you rotate one filter? Um, with two filters, if the polarization is the same, the light can just go right through. But if they're perpendicular to each other, then the light is blocked because the light that went through the first filter is polarized in this direction, and the light went through the second one is polarized in this direction. So it doesn't work; it blocks it out. Um, why does having a third filter diagonally in between the first two filters allow light to pass through all three? If a third filter is put between, then the light only has to turn 45 degrees. It can make that turn, so it's like from this to that, and it can do that instead of just going straight to 90 degrees. And then another 45 degrees after the second filter to the third filter. So most of the light can still make it through. Um, Station 7, why does it appear as though the test tube with oil disappears when placed in the beaker with oil but not with water? The test tube oil disappears in the oil because the light is being refracted the same between the oil in the beaker and the oil in the test tube, so it doesn't change the path of the light very much. You can only see the glass and you can barely see it. You can see the test tube in the water container because the water refracts light differently, so it changes the path of light after it goes through the oil into the water and then back to the